Let us see a question of GATE 2024, which is of multiple choice question and which carries 1 marks. The question is, for the initial value problem y dash is equal to f of xy with y of x naught is equal to y naught, generate the approximations yn to y of xn, where xn is equal to x naught plus nh for a fixed x greater than 0 and n is running from 1, 1, 2, 3 and so on. Using the recursion formula, yn is equal to yn minus 1 plus a k1 plus b k2, where k1 is equal to h into f of xn minus 1 yn minus 1 and k2 is equal to h into f of xn minus 1 plus alpha h yn minus 1 plus beta k1. Which of the following choices for alpha a, b, alpha, beta for the above recursion formula gives the Runge-Kutta second method of order 2 ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಅಂದರೆ we have some options for different choices of a, b, alpha and beta. So what they ask is, they have given initial value problem with the recursive formula and they have to find the values of the unknowns a, b, alpha and beta, so that the recursion formula will give the Runge-Kutta method of order 2. So first what we have to do is, we have to know what is the general formula for Runge-Kutta method of order 2. So we write what is the Runge-Kutta method of order 2 in general ways. So the general Runge-Kutta method of order 2 is given by the recursive relation yn is equal to yn minus 1 plus w1 k1 plus w2 k2. We can write in terms of AB only, so we can write in terms of AB, so that will be very helpful. AK1 plus BK2 with K1 is equal to h into f of xn minus 1 yn minus 1 and K2 is equal to h into f of xn minus 1 plus alpha h yn minus 1 plus beta k1, such that a plus b is equal to 1 and b alpha is equal to half, a plus b is equal to 1, b alpha is equal to half and b beta is equal to half. So just we have to compare this recursive formula with the recursive formula given. So this is the recursive formula given and this is our recursive formula. So what we have written is this. Just we have to compare the values. They asked for what values of a, b, alpha, beta. The considered method will give Runge-Kutta method of order 2. So first take the option. So first we have to check the basic a plus b is equal to 1. A plus b is equal to 1. We have to check the options. So for option A plus b is equal to, here a plus b is equal to 2. For option B, a plus b is equal to 1. For option C, a plus b is equal to 1. For option D, a plus b is equal to 1. So for option A plus b is equal to 2. Therefore option A is not correct option. So we have to check B, C and D options for beta alpha is equal to half and B beta is equal to half. So for the second option B, for option B b is equal to 0.5, alpha is equal to 2. Now b alpha is equal to 0.5 into 2. So this is equal to 1 by 2 into 2. This is 1. So we have to get a half, but b alpha is equal to 1. Therefore option B is also not the answer. For option C we have b is equal to 0.75, alpha is equal to 2 by 3. Now b into alpha is equal to 0.75 into 2 by 3. So this is nothing but 75 by 100 into 2 by 3. So we can make it simplified. 2 ones are 250s, 3 ones are 325. So this is 25 ones, 25 twos. So this is 1 by 2. B into alpha is equal to 1 by 2. Now we have to check for B into beta. Now B into beta is equal to 2 by 3 for option C. Now B into beta is equal to 75 by 100 into 2 by 3. So this also will give 1 by 2. So therefore option C will hold all three relations. A plus b is equal to 1, b alpha is equal to half and b beta is equal to half. Now we will check for option D also. For option D, because a plus b is equal to 1 for option D also. Now b is equal to 0.5, alpha is equal to 1. Now b into alpha is equal to 0.5 into 1. So this is equal to 1 by 2. And for option D, beta is equal to 2. Now b into beta is equal to 0.5 into 2. So this is 1 by 2 into 2. So this is 1. So b into beta is equal to half. The relation will not hold. Therefore option D is not the correct option. Therefore Option C is the correct option because that only satisfies all the three relations. A plus B is equal to 1, B into alpha is equal to half, and B into beta is equal to half. So this is how we can find the unknowns A, B, alpha, beta, so that the recursive formula will give the Runge-Kutta method of order 2.